Alright, it's time we start fixing this crazy moving ramp of ours. And I think step one is going to be to stop simulating movement by constantly setting the position of this thing and to start making this thing act like a real moving object. And we do that in the Box2D world, not by setting position, but by setting its velocity. So let's do that now. So we're back here in our bonus shoot actor. And I'm going to delete this code here. And instead, I'm going to use a nifty little function that Box2D gives us to set the velocity of something called setLinearVelocity. This just determines what direction in the x and y axis that our body is going to be traveling. Now this thing wants v2vec2 as a parameter. And for now, I'm just going to make our x value, say, 2 meters a second times our direction, and our y value is 0. Where am I getting these numbers from? I'm just kind of making it up, but I think this will work probably pretty good. Now when we run this, you'll notice two things. One is that our ramp still appears to be sinking. As we let this thing kind of play out, you'll see that our ramp is slowly moving its way back down the screen. However, on the bright side, our ramp seems to be acting a lot saner. Yes, it's colliding with things, but it's sort of colliding with them in a much more realistic manner. It's not moving back and forth in a crazy sort of way. So that's kind of a good sign. That at least I think lets us know that we're probably on the right path, but the trick is we have to look at why this thing is sinking. Now it turns out if we were to take a look at the output window here, you'll see that the y velocity is constantly being set to 0. So we're not getting quite the same problem as before, but we're getting a pretty similar problem. What I think is happening is, at this point here in the child-specific updating function, we are correctly setting the y velocity of this thing to 0. However, before this function gets called, our Box2D world does call the step function. And this function basically applies the force of gravity and makes our chute move down a little bit. And, sure, we kind of correct that and stop it here, but we don't actually do anything to counteract the forces of gravity that have already been applied to it. Now, maybe we could kind of eyeball this and figure it out by setting it to something like minus 0. I'm going to try this. I actually haven't tried this before in my tutorial, so we'll see what happens. It's actually sinking a little less. And I'm sort of thinking that maybe with enough fooling around, I could actually get these numbers to match up exactly. But clearly, this isn't the best way to solve the problem. Let's look at a slightly smarter way of solving it. However, I will warn you in advance that this is still kind of hacky. So if you want to find a better way of moving things, go right ahead. Just kind of follow the same principle I'm about to do. So first and foremost, let's delete our old code here. And let's go back to actually looking at our ideal location. This is kind of a concept we had in our old code. I'm going to make it a v2vec2 this time just to keep all my data structures sort of similar. And we're basically going to look at our costumes x, and we're going to add our direction times 2 and our y position. So much like in the old version of this algorithm, we're saying that our ideal location is 2 pixels either to the right or to the left of where we were before. Actually, this number 2 is bugging me. I'm going to make it a constant. All right, better. So we know where we want to get to. Let's figure out how to get there. So I'm going to create another vector called direction to travel. And it's basically going to be the difference between where my sprite is now and where I want it to be. And so our x value is going to be our ideal location x minus our costumes x, and our y value is going to be our ideal location y minus our costumes y. So far, so good. And then, like I mentioned before, this vector is probably going to be something where we're moving to the right a little bit, and then we're moving up just a tiny little bit. And Maybe we can use a little trace space statement to find out exactly what that is. Okay, so now that we've got the direction we want to travel in, first things first, let's convert it to meters. And we'll do that by taking our direction to travel, and we will multiply by 1 over our ratio, because B2 vectors don't seem to have a divide function. So now let's see what happens if we take this distance to travel and we set this as the velocity of our body. We'll run this and well, we're not moving particularly fast here. It does look like our platform is very, very slowly moving to the right, but yeah, it's doing it pretty slowly. And the reason for that is basically we have figured out the distance we want to travel. However, we figured out the distance we want to travel in one frame. The distance we want to travel in 1/30th of a second. And when we're setting velocity, we set velocity in meters per second, not per 30ths of a second. So to fix that, we can take our direction to travel and multiply by our frame rate, which in this case I know happens to be 30. So we've taken the distance we want to travel in one frame in meters, and we've converted it to the distance we want to travel in 1 second in meters. And that's how we're going to get a velocity value that actually works. So let's try it. Hey, wow, we've actually got some fairly smooth motion with our platform. I don't know about you, but I'm pretty excited. And if we look at the output, by the way, from our Flash program, you can see that we're traveling at a speed of 2 meters a second, either to the right or to the left, and then negative 0.35 or negative 0.3, a little bit upwards, basically just to counteract the effect of gravity that you're getting every frame. So like I was saying before, for basically a straightforward back and forth motion, this might be a little bit of overkill. This is fairly complicated. But if you do for some reason have a fairly complex path that you want your moving object to travel around, you could use some technique like this to actually make it work. You just figure out the point you want your object to travel to, figure out the velocity it would need to travel to get there, make sure you've converted from pixels to meters, and make sure you've converted from frames to seconds, and it should all work. Alright, so let's do a few more things. One thing, by the way, you might want to do, I don't like having to hard code this frame rate here. We've hard coded it in here, we've hard coded it over in this step function in our Puggle application. It does seem like at some point if I change the frame rate, I'm going to forget to change one of these. So if it makes you feel better, and maybe this is just me, but you could certainly create another constant over in your physevals file, and then you can change it here in your new frame listener. And we can change it over here in our bonus shoot actor. Obviously, this still isn't quite ideal. If I change the frame rate, my platform is going to move at a different speed than before, and that's just because of the sort of crude way we're making it move. There's probably smarter ways of doing this. I'm sure you can think of some, so I will leave that as an exercise to the reader, which basically means I'm too lazy to do it myself. And basically, let's move this thing back down to close to the bottom of our world here. Alright, so let's try this again and see how it looks. Alright, we got it moving left and right. That's pretty good, and it's doing it at a constant rate down at the bottom of our screen. So I'm pretty happy with that. Let's toss a few balls at it. Alright, well, we've got a little weirdness going on. Looks like first thing is we're getting some little rotation going on whenever it collides with the ball. So I think we're going to need to fix that. The other issue, and maybe it's one that you can't quite tell here, let me quit and restart and see if I can show it to you, is that, I don't know if you saw that first ball that I shot out, it should have collided with the corner here, and it didn't. It seemed to pass right through it. That's also an issue that we should probably address. And so we'll take a look at fixing both of these little outstanding bugs in our next lesson.